When you're a big airplane, you need a big landing gear. So let's talk about landing gear systems. And first of all, the shock struts on the landing gear. The shock struts support the aircraft on the ground, and they also act as shock absorbers to cushion the stress of landing. And some landings certainly have a lot of stress in them. Now, when you look at a cutaway of an air oil or oleo shock strut, we have oil in it, we have compressed air in it, and there also is a metering pin. And the metering pins in the shock struts, the purpose of them is to cushion the initial shock of landing, and they do that by retarding the flow of oil as the strut is compressed. Because as that strut is compressed, the fluid is forced through a metered opening, and that makes it compress slowly. So the purpose of that metering pin is to cushion the initial shock of the landing. Now, when that shock strut has compressed from a landing, to prevent a very rapid extension of it after that compression, there will be various types of valves or orifice in the shock strut which restrict the reverse fluid flow, and that keeps it from extending too rapidly after it's been compressed. And there will also be a sleeve or spacer or bumper ring incorporated in that shock strut, and the purpose of that is to limit the extension stroke. They limit the extension stroke. Now, when you take a look at a shock strut, one of the things that you'll notice is torque links. The torque links are attached to the cylinder and the piston on the shock strut, maintain the correct wheel alignment, because otherwise the piston and the cylinder would just simply be able to rotate independently, and that tire wouldn't stay lined up the way it's supposed to. So the purpose of the torque links there is to maintain the correct wheel alignment. Now, the nose gear also has a cam incorporated in the nose gear shock strut, and the purpose of that cam is to straighten the nose wheel, to make sure you've got a straight nose wheel when you touch down. As you get into large aircraft, ones with hydraulic steering, you're going to have a steer damper on the nose wheel. And the purpose of the steer damper is twofold. First of all, it hydraulically steers the nose wheel. This is on aircraft like 727s and the large airline aircraft where you have hydraulic steering instead of just using the rudder pedals. And the second purpose of that steer damper is it acts as a shimmy damper to keep that nose wheel from shimmering. One of the things the FAA wants you to know is that if you have a steer damper on the aircraft, it's going to have high-pressure hydraulic fluid on the inlet of the steer damper. And if that high-pressure hydraulic fluid is removed, if it doesn't have high-pressure fluid anymore on the inlet of the steer damper, you will still have automatic damping action. It needs the high-pressure fluid in order to do the nose wheel steering, but if that high-pressure fluid is removed from the inlet, and you need to know that it's from the inlet on the steer damper, even though you don't have the nose wheel steering, you will still have an automatic damping action from that steer damper. Now let's talk about the seals that are used in the shock struts. Chevron seals, or V-rings, and notice the V in here in the shape of the seal. Chevron seals or V-rings are used in the shock struts, and the purpose of them is to prevent oil from escaping. Not air from escaping, but oil from escaping. And you need to know that when you're installing a Chevron type or V-ring seal in an aircraft hydraulic cylinder, it is the open side of the seal, that should face in the direction that the fluid pressure is coming from. Now, on a landing gear shock strut, the hydraulic packing seals in it can be used only with a specific type of fluid. Whether they're natural or synthetic packing seals, you can't just mix and match on the fluids. You've got to make sure that the hydraulic packing seals that you use are compatible with a specific type of fluid required by the manufacturer. Now, let's assume that a pilot comes to you with a complaint about a shock strut. And what he says is during landing, that shock strut bottoms out. It bottoms out during landing, particularly if you do a kind of a hard landing, but it functions correctly during taxi. If that's the complaint, what you want to check for is low fluid level. And the reason for that is, remember that we said that the landing shocks are absorbed by the oil movement, and the metering pin controls that oil movement. Taxi shocks are absorbed in that by the compressed air. So if it bottoms out during landing but works okay during taxi, then it is the fluid level that is probably going to be the problem, a low fluid level. Now, what kind of fluid do you put in, and how much air pressure do you put in a shock strut? Well, where you find that is in the aircraft manufacturer's service manual. The aircraft manufacturer's service manual will tell you exactly how to service a particular shock strut. Now, on most aircraft, the way that you check the oil level of an air oil shock strut is that first you have to release all the air and then see that the oil is up to the level of the filler plug. So you've got to release the air first to check the oil level, and then see that the oil is up to the level on the filler plug. When you take a look at an air valve core, if you see a raised H on the stem, that raised H means that the valve core is a high pressure type. And you want to make sure whether you're working with a high pressure or low pressure type. The raised H is the indication of a high pressure air valve core. Now, how do you determine the proper operating position of the strut? One way is to measure its extension. With the airplane on jacks, you can measure the extension of that shock strut and see if it's in the proper operating position. Now, if an empty shock strut is being filled, you need to make sure to extend and compress that strut completely, at least 2 times, the FAA says, to make sure that the packing and rings are seating properly and that you get all of the air bubbles out. So when you're filling an empty shock strut, extend and compress it at least 2 times to make sure that the rings and the packing seat properly. By the way, if you're going to service an air oil shock strut, the correct way to do it is first you want to collapse the strut and then add fluid up to the filler opening, install the air valve core, and then inflate the strut. You do not want the strut partially or fully extended because you won't get the oil at the right level if you do that. Now, if you've properly serviced a shock strut and it still bottoms out after you've properly serviced it, what that means is you now are going to have to remove, disassemble, and inspect the shock strut because you've properly serviced it with oil and with air, and if it's still bottoming out, it's got some much more significant problem. You're going to have to remove it, disassemble it, and inspect it. Now, some aircraft have electric gear retraction systems, but larger aircraft very frequently have hydraulically actuated landing gear. The airliners in particular have hydraulically actuated landing gear systems, and in that kind of systems you have gear doors and fairings and landing gear. The order of gear and fairing door operation is controlled by sequence valves. There are sequence valves in the hydraulic systems that control the order that the various gear and doors are going to be moving in a hydraulically actuated landing gear system. Now, as the gear retracts, you've got a nose gear centering cam, and the purpose of that nose gear centering cam is to center the nose wheel before it enters the wheel well, because if the nose wheel went in crooked, then you could have a problem as far as the gear jamming or doing damage when it's retracted. So the nose gear cam centers the nose wheel before it enters the wheel well. Now let's assume you've been doing maintenance on the landing gear of an aircraft. On the landing gear gear retraction system. If there is any possibility that the maintenance may have affected the landing gear's ability to retract or expand properly, it is very important to make an operational check of the landing gear retraction with the aircraft placed on jack. So if you've been working on anything that might affect the gear retraction system, make sure and cycle the gear with the airplane on jacks and make sure that it's working properly. For example, an example of a repair that would require a landing gear retraction test is if you made a repair on the gear downlock micro switch. If you made a repair on the gear downlock micro switch, that might affect the landing gear retraction system, and you need to test the landing gear on jacks after that repair is done. Now, when you've got an aircraft with retractable landing gear, you're going to have some landing gear warning devices. What do those warning devices provide? Well, the landing gear warning devices will usually provide some lights, a red warning light, for instance, for an unsafe gear condition, a green light for gear down, and no lights at all for gear up. And in addition to that, there will usually be a horn or other oral device that tells you if you've got an unsafe gear condition. So the red warning light is if the gear is not safe, it's not down and locked, or it's not up and locked. A green light if the gear is down, and no lights at all if the gear is up. Now, the landing gear warning system is going to provide a warning in the cockpit if the throttle is retarded and the landing gear is not in the down and locked position. So when you pull the throttle back, if the landing gear is not down and locked, what you're going to get is a warning horn that under some conditions can be silenced, but under other conditions cannot be, depending on the particular configuration of aircraft. Now, every airplane that's got a retractable landing gear has to have some means to extend that landing gear if the normal operating mechanism fails. In this particular case, we've got a lever here to pump the gear down. Some aircraft have compressed air or compressed nitrogen that will blow the gear down. All kinds of different ways to do it depending on how big the aircraft is, but there's got to be some alternate way to get that landing gear down if the normal operating mechanism fails. Now, there's also going to be a ground safety switch. The ground safety switch is located on the main gear shock strut, and it's actuated by when that strut compresses and extends. It extends fully, of course, once the aircraft has taken off and it's in the air. This ground safety switch is very often called the squat switch. It's got a lot of functions, but one of the functions is to avoid accidentally retracting the gear when you're on the ground, because what it will do is when that strut compresses and activates that switch and says, okay, there is weight on the aircraft, and I know there's weight on it because the strut has compressed and it's activated this ground safety switch, it will not let you, theoretically anyway, raise the landing gear, because it says, hey, I'm on the ground, I don't want the gear up. And then after you take off and the strut extends, then you will be able to retract the gear, because that ground safety switch says, hey, I know you're airborne, that's okay for you to go ahead and do now. Now let's talk about brake systems on the aircraft. First of all, independent brake systems. An independent brake system simply means that it's one with its own reservoir and it is completely independent of the main hydraulic system in the aircraft. So even if you have hydraulically actuated flaps or thrust reversers or whatever, if the aircraft has an independent brake system, it's completely independent of the aircraft's main hydraulic system, and that's the way a Citation is. A lot of hydraulics in it, but the brake system is independent of the main hydraulic system. The purpose of that compensating port is to allow fluid to flow toward or away from the reservoir as the temperature changes. This prevents a buildup of pressure when the brakes are off. port. Now, if that compensating port is restricted, it can have an effect on the brakes. And one of the effects that it will have is to cause slow release of the brakes. If the fluid is not able to go back out through this when the spring is pushing back on the piston, it will tend to cause slow release of the aircraft brakes. Now, let's assume that a pilot reports to you that the left brake on an airplane is dragging. The left brake is dragging excessively. One cause, the most probable cause under the conditions the FAA will give you, is foreign particles stuck in the master cylinder compensating port. Because if there's foreign particles in here, if that port is restricted, the brakes will not release properly and the brake is going to drag. Now, another thing that could cause the brakes to drag is if this piston return spring is broken. The piston return spring is supposed to push that piston back and take the pressure off of the brake system when you take your feet off the brakes. But if that spring is broken, then it's not going to push the piston back and the brakes would not release. The brakes would drag. Now, let's suppose that a pilot who's just landed doesn't like the way his brakes worked on landing. And the complaint that he comes into you with is that the brake pedals have excessive travel. They go down too far before they grab hold. The probable cause of that is a lack of fluid in the brake system. Now, with the brake master cylinder unit, if you get internal leakage in that unit, one of the things that it can cause is the pedal to slowly creep down while the pedal pressure is applied. That is not the same as fading brakes. Fading brakes are the result of overheating the brakes and glazing them. But the pedal slowly creeping down while you've got the pedal pressure on is probably the result of internal leakage in that brake master cylinder unit. An internal leak like that will also cause the parking brakes to continually creep to the off position. They just simply aren't holding the pressure because of that internal leak. Now, as aircraft get faster, they need more than just the master cylinder to help them in getting stopped. So power boost brake systems are used on aircraft that have high landing speeds. 747 needs a lot of power in order to stop it. So power brake systems are designed for aircraft brakes on aircraft that need a large volume of fluid to operate the brakes. And in power brake systems, you're going to be using power brake control valves. And basically what you're doing in power brake systems is you're using the aircraft hydraulic pressure, of which you've got a lot of pressure and a lot of fluid, to operate the brakes through the power brake control valve. So the pressure source for power brakes is the main hydraulic system of the aircraft, which is different than an independent brake system. The independent brake system, remember, had its own separate reservoir, its own master cylinder setup. Now, in a power brake system, one of the things that will always be in the system is a relief valve. And the purpose of that relief valve is to compensate for thermal expansion in the hydraulic system. Power brake systems will also have debooster cylinders or valves. Debooster cylinders or valves are used to reduce the pressure to the brake. Here's the way that debooster valve works. You've got hydraulic pressure coming in the top of this debooster valve, and its aircraft pressure could be 1,500 psi. Well, the brake assembly on the wheel is not designed to take that kind of high hydraulic pressure. So what the debooster valve does is take that high pressure, relatively small flow of hydraulic fluid and change it to a large volume of fluid at much reduced pressure. What you have at the top of the debooster valve is a small cylinder, and there's a ball check valve there. But down towards, on the other end of that small piston is a big piston head in a bigger cylinder. So when you put a lot of pressure on this small piston head, it translates into a lot less pressure, maybe 300 psi, but a lot bigger volume of fluid moving out of the cylinder, debooster cylinder down at the bottom of it, moving on down into the brake assembly. So what the debooster cylinder lets you do is it reduces the pressure to the brake, takes it down from high pressure down to low pressure but high volume. It increases the volume of fluid flow, and also it releases the brakes rapidly. And the way it releases the brakes rapidly is this. You put your feet on the brakes and the pressure pushes down on this small piston. This whole piston assembly moves down towards the bottom of the cylinder. When you take your feet off the brakes and the pressure is released up here at the top of the cylinder, this piston return spring, which comes up like this piston return spring will rapidly force that whole piston assembly back up to the top of the debooster valve. And as it pushes it rapidly upwards, it creates a suction effect down here, and that pulls the pressure off of the brakes very rapidly, so it allows you to release the brakes rapidly. Now, if you're using a brake debooster valve in a power brake, hydraulic brake system, where is it going to be located? Well, in this system here, you've got the power brake control valves, you've got anti-skid control valves, which we're going to be talking about later. Here are the debooster cylinders, the shuttle valves at the brake, and then the brake assembly itself. So where the brake debooster is going to be located on the choices they give you is between the power brake control valve and the brake actuating cylinder that is down on the brake assembly. Now, in regard to debooster valves, the FAA wants you to know that lockout deboosters will generally allow full debooster piston travel without having fluid from the high pressure side enter the low pressure chamber on the debooster valve. Okay, let's talk about anti-skid. This tire, as you can see, has had a bit of a skidding problem. Anytime a wheel goes into a skid on an aircraft, effectively the aircraft can't brake anymore. The aircraft's braking value, as the FAA puts it, is greatly reduced if a wheel has gone into a skid. On small aircraft, it's basically up to the pilot to put on maximum braking pressure without actually skidding the wheels. But on larger aircraft, particularly in the airline category, you'll have an anti-skid system, an automatic system that takes care of it for the pilot. Now, the anti-skid system is an electro-hydraulic system. There are electric sensors, and there are also hydraulic components to it in the anti-skid system. Now, the anti-skid system has basically three components. What you have is wheel speed sensors, which are on the wheels themselves. You have a control box, basically a brain, and you also have control valves. Wheel speed sensors, a control box, which is the brain of it, and control valves, which actually pump the fluid through. Now, what the skid control system is designed to do is this. There are four functions of it: normal skid control, locked wheel skid control, touchdown protection, and fail-safe protection. The fail-safe protection means if this thing fails, it's not going to mess you up. You're still going to have brakes. The touchdown protection will keep you from having the brakes on when the aircraft actually touches down. The locked wheel skid control is when the anti-skid is actually doing its thing because you're on ice or water or something that's causing the aircraft to skid, and it's doing its normal anti-skid function. Normal skid control is when the wheel rotation is slowing down, decelerating enough that it indicates an impending skid, and the anti-skid system releases the brakes a little bit to increase the speed of the wheel rotation. Okay, how does the darn thing work? In the anti-skid system, you've got this electrical sensor down on the aircraft wheel. So if the wheel is skidding, it's detected by this electrical sensor. It's basically a generator, an anti-skid generator, and that generator measures the wheel rotational speed. It measures the rotational speed and the trend, any speed changes. Now, when it senses that the wheel is approaching a skid, an electrical signal is sent by the control unit, the brain, to the skid control valve. And the skid control valve relieves the hydraulic pressure on the brake. So here are our anti-skid control valves, and that's what's going to relieve the hydraulic pressure on the brake when it receives a signal from the control unit, basically the brains of the system. Now, the anti-skid system, the way it's designed is to apply enough force to the aircraft brakes to operate just below the skid point. In other words, it's going to put on maximum pressure, but the minute it senses a wheel approaching a skid, it will release the brakes and then put on just a little bit less pressure so that it is always trying to apply enough force to operate just below the point where the wheels are going to skid. Now, when the airplane is slowed down but not quite come to a stop, the airplane is below, for instance, approximately 20 miles an hour. At that point, the anti-skid system deactivates. It deactivates, and the pilot then will have normal skid control, which means he'll be able to put on a brake and kind of pivot around it. He's going to be able to use the brakes to help him on the taxi and on maneuvering the aircraft. Now, the anti-skid system is deactivated on takeoff, and what deactivates it is the landing gear safety switch. That same landing gear safety switch we talked about before on the main gear strut, when it closes at liftoff, the anti-skid system is deactivated. In the air with the anti-skid armed, current cannot flow to the anti-skid control box because the landing gear squat switch is open. What this means is you cannot apply the brakes until the weight is on the wheels. And that's good because it prevents landing with the brakes locked and blowing the tires. It is activated or armed in most installations by a switch in the cockpit. And in a 727, that switch is in the overhead panel above the captain and the co-pilot. So you've got a switch there where it's activated or armed that you turn on before landing. Now, if there is a problem with the anti-skid system, if there's a system failure, or if you've simply turned off the system, there will be a warning lamp that lights that tells you that the anti-skid system is not activated for one reason or another, that it's either turned off or that there has been a system failure. Now, we've talked about different ways to actuate the brakes. Let's talk about the brake assemblies themselves. On small aircraft, small general aviation aircraft, what you'll typically find is this type of brake system, which is single disc brakes. And with a single disc brake system like this, you want to make sure to keep equal pressure on both sides of this rotating disc. And the way that you assure that you will have equal pressure on both sides of the rotating disc is by keying the disc loosely in the wheel so that it can move from side to side. And by moving from side to side, you will keep equal pressure on that rotating disc. Now, if you've got a brake system with single disc brakes like this and also a master cylinder, meaning an independent brake system, let's suppose that the pilot reports to you that he's got excessive brake pedal travel. Too much travel on the brake pedals to get the brakes on, but he also says that the brakes are hard and effective. Good brakes, but lots of brake pedal travel. Probable cause on that is worn brake linings. What you'd want to check for there is worn brake linings. Now, as aircraft get larger, typically you'll find them equipped with multiple disc brakes. Multiple disc brakes look very similar to the single disc brakes, except they've got a lot more of those rotating discs. Now, if you've got an aircraft that has multiple disc brakes, and the pilot reports that he's got sluggish and jerky brake operations, one of the things that you need to do is to disassemble and clean the automatic adjuster on those brakes. Now, what's the automatic adjuster? The automatic adjuster on a multiple disc brake system, on brake release, it traps the correct amount of hydraulic fluid in the brake, and what that does is it gives the correct clearances between the rotating discs and the stationary discs. And if that automatic adjuster gets contaminated, it gets particles in it and so on, then you're going to have sluggish and jerky brake operation. So sluggish and jerky brake operation in a multiple disc system like this could be due to a dirty automatic adjuster. Disassemble it and clean it. Now, if you've got hydraulically operated multiple disc type brakes like this, one of the things you do not want to do is set the parking brake when the brakes are hot. Because if you set the parking brake when the brakes are hot, what can happen is the heat buildup in that brake system can actually warp the brake discs. Discs are better quality than they used to be. It's not as much of a problem as it used to be, but it can still happen, so don't set the parking brake when those brakes are hot. Now, there's another type of brakes called the expander tube brakes. With expander tube brakes, what you actually have is a neoprene and fabric tube inside the brake area right here. This is the brake assembly, and you have a neoprene and fabric tube in here. And that fabric tube, neoprene and fabric tube, expands and contracts as hydraulic fluid is forced into and then leaves that tube. Now, most brake types can be adapted to operate either mechanically or hydraulically. But this type of brake, the expander tube type of brake, is not adaptable to mechanical operation. They are only hydraulically actuated because it has to have hydraulic fluid going into that neoprene tube. It's the hydraulic fluid that expands it. There isn't anything there for a mechanical system to operate on. You've got that tube that has to have hydraulic fluid in it in order to expand and in order to put on the brakes. It is not adaptable to mechanical operation. Now let's talk about bleeding the brakes. What bleeding the brakes is the process of getting the air out of the system. And the way you do that is by withdrawing fluid from the system in order to get the air out. And what we've got here, here's our brake fluid reservoir, the master cylinder. Down here is the wheel assembly, and here is a tube coming off of the bleeder valve going down into basically some kind of container that has got hydraulic fluid in it, so that you can bleed it off and make sure that you don't get any air back into the system by keeping that tube down under the oil. Now, how do you tell when you've got all the air purged out of the brake system? Well, what you do is you submerge this bleeder hose into hydraulic fluid, some kind of container with hydraulic fluid in it, and you watch, and what you're watching for is air bubbles. And you put pressure on that master cylinder and you watch as the air comes out, and eventually all the air bubbles will have escaped, and at that point you finish bleeding the brakes. You've got all of the air out of the system. Now, another way you can tell that you've got all of the air out of a master cylinder brake system like this is by checking to see whether the brake itself is firm or spongy, because usually when you have spongy brakes are usually a result of air in the system. So if you've got spongy brakes, you've still probably got air in the system. Now, I say probably because there is another possible cause of spongy brake action. And the next most likely cause of spongy brake action other than air in the system is deteriorated flexible hoses. If the flexible hoses are in poor condition, the material has actually deteriorated, what will happen is that those hoses will then expand under pressure, and that's going to give you spongy brake action, very similar to feel to if you had air in the system. Let's talk now about aircraft wheels and tires. And let's start with this interesting nose wheel tire off of a citation. You'll notice around the edge of the tire there's a little lip of rubber that extends on each side, and that's called a chine. The purpose of the chine on a nose wheel tire is to help deflect water away from the fuselage. So as the airplane is on a takeoff or landing run, water will tend to be scooped off to the side and deflected away from the fuselage, and the idea behind that is it reduces water spray going into the engines. Aircraft wheel assemblies are balanced, and the primary reason for balancing the aircraft wheel assembly is to prevent heavy spots and to reduce vibration. You want that tire to roll smoothly. You don't want to have a heavy spot where it always hangs in one position, and then when you land, you're always landing on the same spot. And you want to make sure that you don't have vibration on takeoff and landing. Now, let's assume that you've got split rim tires. If you've got split rim wheels, the tire and wheel manufacturers will usually recommend that you deflate the tires before you remove the wheel from the axle. Here's an example of a split rim wheel. This particular one is off of an F-16. But they recommend that you deflate the tires before you even take the wheel off the axle. And the reason for that is it's a safety precaution just in case the bolts that hold the two halves of the wheel together have been damaged or weakened. Because if they have been damaged or weakened, there is a possibility, maybe not real high, but it would still ruin your day, of the two halves of that wheel coming apart explosively, and that would be like having a bomb go off. So deflating the tire first before you even take it off of the wheel off the axle is a good safety precaution. Now, in a lot of cases, a tire will have a stripe or a mark like this that goes from the rim of the wheel down onto the tire. And a stripe or mark like that goes from the rim of the wheel down onto the tire is a slippage mark. And the purpose of that is to be able to look at the wheel assembly and say, okay, has this tire slipped around the rim of the wheel any? If it has, it's an indication of a problem, possibly of some very bad landings, some problem that has actually slipped the tire around the wheel, which is definitely not something that you want to have happening. Now, when you're looking at the landing gear on an aircraft, you want to make sure that you don't have toe in or toe out. So, what is toe in and toe out? If you took the longitudinal axis, meaning the front to back axis on the main landing gear wheel assemblies, one on each side, and if you extended them, if they met aft of the aircraft, on the rear of the aircraft, that would mean that the wheels have toe out. In other words, if the two main landing gear did not point directly straight forward, but the longitudinal axis met behind the aircraft, it would mean that basically the landing gear are pointing outward like that, the wheel assemblies are pointing outward, and that's called toe out. Now, if it were the other direction, that would be toe in. And if you have an out of tolerance toe in or toe out condition on the main landing gear, and it's not the fault of something being bent or twisted, in other words, nothing's been damaged, but nonetheless there's too much toe in or too much toe out, the way that that is corrected or repaired is simply by putting washers or spacers in. You insert them, remove them, change the location of washers or spacers at the center pivotal point of the scissor torque links. So what you're doing is changing washers and spacers at the pivotal point on the scissor torque links in order to correct a toe in or a toe out condition. Now, as far as the tires themselves are concerned, tire pressure should be checked at least once a week, probably more often, but at least once a week, the FAA says. So where do you find the correct inflation pressure for an aircraft tire? Well, you get it from the Aircraft Service Manual. You do not get it from the manufacturer of the tire because the inflation pressure will vary from aircraft to aircraft, even for the same tire. Now, when you're looking at tires, you can tell whether a tire is overinflated, has been overinflated, or underinflated. An overinflated tire is going to tend to cause excessive wear right in the center of the tread. And the reason for that is too much pressure. It's basically just the very center part of the tread that's going to be in contact with the ground, so you're going to get excessive wear in the center of the tread. And another thing that it can cause is damage to the wheel flange. The excessive pressure here can actually cause damage to the wheel flange. Now, what if the tires are underinflated? If the tires are underinflated, not enough pressure, then basically what will be happening is the shoulders of the tire is where the wear is going to show up. You'll have excessive wear in the shoulders of the tires if the tires are underinflated. Now, how long should you wait after a flight before you check the tire pressure? At least 2 hours normally, but 3 hours in hot weather. Wait at least 2 hours, but 3 hours in hot weather after a flight before you check the tire pressure. Give them a chance to cool off and get down to their normal pressure. Now, assume that you're checking the pressure in tires that are mounted as duals. Here you've got a set of duals, and you're checking the tire pressure on both of them. What if there's a difference? If the difference is more than 5 pounds of air pressure, what you do is correct the discrepancy, but then you enter it in the log book. You need to make a note of it in the log book so that an eye can be kept on those two tires and see if there's some sort of recurring, continuing problem. Go ahead and correct it, but make a note in the log book if there's a difference of more than 5 pounds of air pressure in the duals. Now, let's assume that you're installing tires with tubes. Tubes in newly installed tires, you first want to inflate them, then fully deflate them and reinflate them to the correct pressure. And the reason you do that is to make sure that the tube is going to position itself correctly inside the tire. Inflate it, deflate it, and reinflate it, and then check it for proper inflation daily for several days. A newly mounted tire with or without a tube, you should check it for proper inflation daily for several days just to make sure that it's seated properly and that it's not leaking on you. Now, on the maintenance of the tires themselves, aircraft wheels often have fusible plugs. For instance, this F-16 wheel has got a fusible plug here. Fusible plugs installed in aircraft wheels, the purpose of them is to be a fuse point to melt at a specific elevated temperature. In other words, when that whole tire assembly has gotten really, really hot, rather than the tire blowing up, the fusible plug will melt and it will release the tire pressure. But what that means is that that tire has really been abused. The tire should be scrapped, just thrown away, if it's been subjected to a temperature high enough to melt one of the fusible plugs. If it's melted the fusible plug, it's had enough heat, enough abuse that you need to just simply get rid of it. So how do you guard against heat buildup in aircraft tires? Well, the best way to guard against heat buildup in aircraft tires are short ground rolls, slow taxi speeds, minimum braking, and proper tire inflation. In other words, don't taxi at high speeds on the ground. Try and keep your ground roll on takeoff short. Use minimum braking if the runway length permits it, and make sure that the tires are inflated to the proper tire inflation pressure. Let's assume that you want to minimize the damage or deterioration of an aircraft tire. The FAA will give you a list and say which of these is considered harmful to aircraft tires. And there's a whole bunch of things that are harmful and only a couple of things on the list that are not. Things that are harmful to tires are fuel, oil, ozone, electrical equipment, hydraulic fluid, and solvents, and you want to keep tires away from those items. So what kind of things are not harmful to tires? Well, of the stuff they give you in the list on the test, things that would not be harmful are low humidity and helium. Now, let's assume that you've got high-speed aircraft tires. High-speed aircraft tires are very expensive tires. Can they be recapped? Yes, they can. If they've got a sound cord body and bead, they can be recapped, and the number of times they can be recapped depends on what condition the tire is in. So as far as the test is concerned, they can be recapped an indefinite number of times. An indefinite number because it just depends on how good the condition of the tire is, as long as it's got a sound cord body and bead. Now, what about tire maintenance for a private pilot? As a private pilot is allowed to remove, reinstall, and repair landing gear tires if he owns and operates the aircraft. It has to be his own aircraft. He's not allowed to do it on someone else's. And if he's doing it on an aircraft that he owns and he operates, not one that somebody else operates, that is considered to be preventive maintenance. So a private pilot can remove, install, repair his own landing gear tires on his own aircraft that he operates. He can do it, and it is considered to be preventive maintenance. Well, when you're working with tires and you're abusing them like that, you want to make sure that you give them good maintenance.